All right, good evening, everybody. So yeah, it's your time for 1 hour, and then just ask me anything about your material related to the test. Okay, I will try to monitor the chat at the same time, but you can just feel free to speak up by opening your mic. That's okay.
Hi, good evening, Professor.
Hi, go ahead, please.
Hi, I just have two questions, and they're
Yes,
both regarding the practice problems.
yes.
So the first
So let me
one,
just go there first, and then we'll talk about each one you have. Okay. So 3342, and then example questions. Yes. And then let me just get directly to um, the uh, the final answer. So yeah, just in case. Yes, go ahead, please. Which one?
yeah, so it's the first one, and the first one is unprovable.
Yeah.
I understand that part, but my question is that if we know from the beginning that it's
Mhm.
unprovable, why does the answer want us to put monotonicity at first? I
Yeah.
get why that it's applicable, but
Yes.
isn't the point of monotonicity is for you to eventually use it as the next step for something else? In
Mhm.
this case, monotonicity is not really helpful in any means. And so maybe you can clarify monotonicity
Yeah.
should
Yeah.
be at
Yeah.
first
I,
instead
I
of
I definitely see
just
your point.
being
Yeah.
yeah.
Mhm. Yeah, I think my intention for I think this one again is like an example question. So when I was designing this question here, I thought, okay, I put all the rules over here, and then you somehow want to see which one is applicable for you to make some move, right? So it turns out, in order for you to make a move, monotonicity turns out to be the only way that's applicable. So that's why I said as many rule as possible. So you try with the only rule that's possible for you as a first step. And then after that, it turns out you just get stuck. You cannot apply any more rules. That's why you put a question mark. So that's kind of the initial intention. So I do see your point to say if the sequence already unprovable, why should we actually even bother to put any any inference rule? I would say if I don't think a question like this will be actually on the actual test. I think this one here just to let you practice to see given a sequence what would be the applicable inference rule for you to try and then to see if you really get stuck. In this case, only one sequence possible for you to try, which is monotonicity. And then after that, you just get stuck. That's my initial intention. But in the actual test and in the exam, so I think that because especially for the exam, what you will be given will be just a sequence directly. If you really believe the sequence somehow is unprovable, in general, you still actually have to show some progress and say, okay, I've tried this, and then somehow I believe there's no way for me to make any further progress, right? So does it kind of clarify your concern? Well, not yet.
Um, I guess my concern is for the test.
Mhm.
There will be flexibility when it comes to the grading as because in the
Mm,
first test it
yeah,
was
I
pretty
would
much
say if you're given, well, I don't think this one particularly, like this one here will be there, but just in case, if you're actually asked to really put like put inference rule, so you just have to make sure whatever you put there should be applicable, to the sequence. In this case, since I put the constraint over there to say as many as possible, so what you really want to think is from this one here, is it possible for me to at least to try from all the possible inference rule over here, at least one that's going to work. The monotonicity turns out to be the only one that's going to allow me to drop some sequence, some hypotheses. But it turns out even by applying this, in the next step, I'll get stuck, right? So
okay.
yeah,
Okay.
so I think that's kind
But
of this is not really like a perfect question, to really test. But I would say just one example, right?
okay.
Mhm.
So all right.
Second one,
And
please.
yeah. So my second question is to do with the last question. I was having an email exchange with you about
Yes,
this.
yes, yes, yeah. I'm glad
Um
you asked here. Let's clarify together.
yeah.
Okay, no
Yeah.
problem. Okay,
So
let's read it
for
together.
those
That's
of
okay. Yeah, I do
yeah.
see what your confusion might be. Let's read it together and then also benefit your classmates. So we want to prove about invariant preservation in a refinement. Let's say M1, right? That's the refinement we are learning. So here I say only concrete events with abstract counterparts should be considered, meaning that only the old events should be considered. Okay, so this strictly speaking is false in the following sense. So let me show you guys what I meant. So let me put something on the iPad, and then I'll show you how you can see this. Somehow this was not exactly explicitly shown on the slides, right? So somehow you have to follow very carefully about the flow. Okay. So first of all, let me just put over here. So when we talk about invariant preservation, right? That's one of the very important proof obligation rule. Invariance preservation. Okay, so for this one here, basically is going to be applicable to all the concrete events. Okay, and if you recall what we said on Tuesday, and that one, their concrete events include both the old events and also the new events. And of course, in our case, old will be ML out and also ML in. And also new will be IL in and also IL out, right? So that means all these four events should really be proved with respect to the invariant preservation. Let me first of all show to you where they are, okay, in the slides. So maybe that's rough. That's something you were confused about. Let's take a look at the slides. Okay. Okay, so if I can go to, let me just go to refinement number 1, and then I'll try to find it. Okay, we're getting there. Okay, so here, this is refinement 1 already. So you can see, okay, that's guard strengthening, and then invariant preservation. So here, you can see here the 10 that we are talking about. Those are the 2 times 5, right? The 2 ML out and ML in. So these are the old events, and then times the 5 invariants. So we got 2 times 5. And then that's the invariant preservation. And later, I believe that was back on Tuesday, when we spoke about also invariant preservation, right after this, right? We talk about new events. I think there was somewhere that we talk about invariant preservation over here, right? You can see here we got IL in and IL out. In that case, we got another 10 because we got IL in, IL out 2 times 5. So in total, how many sequence should we really generate just for invariant preservation, right? So if we go back to the slides over here, basically it will be 10 and 10 over here. And this one here is slide number 71. And that one there, just for your reference, right? Somehow I kind of discussed them separately, right? So that one there, let me just put down the reference number there. That one is slide 59. Right, so bottom line, for invariant preservation, you have to make sure both the old and new events, or in general, concrete events, they should be proved with respect to invariant preservation. So in total, how many sequences do we need? We need 20, okay? So now if we go back to the actual question. So this question over here, it says that only the old events should be considered. So that one, strictly speaking, is not right, because you also need to consider the new events. Okay. So Rava, does it help?
Yeah, no, that makes sense. So
Okay,
just
right.
to
Yeah.
clarify one last time, the formula should be in brackets, number of old events plus new events.
That's correct.
Times
That
the number of invariants. Okay.
That's correct.
Okay.
That's correct. Like over here. Yes. Okay.
Yeah. Okay. Got it.
Okay, no problem. That's good. I'm glad to clarify. Okay, so one question from Ryan from the chat. Question for number 10. Okay, let's see. Number 10. Okay, let's take a look. Let's see what the question is. Okay, let me remind myself over here. Okay, I see. So over here we are, this one is intended to be the guards of some events. So we want to say one guard should be the cars on the bridge heading to the island, right? That one doesn't seem to be the problem. But now cars which have left the mainland, are limited. Basically, cars which have left the mainland could either be on the bridge, which will be A, or it could be on the island, which will be B. So A plus B should be bounded. And now we got 2 options over there. Either A plus B is less than or equal to D, or A plus B less than D, right? So Ryan, I suppose you actually chose K over here, right? Rather than F. But I believe F is the answer. Okay, so here we're just talking about the number of cars on the bridge and on the island, the island bridge compound should be bounded. In that case, having smaller than D might be a little bit too strict. So let's say, for example, let's say we allowed up to 10 cards inclusive, on the island and the bridge. So now you're saying that if I'm only allowing, let's say, for cards over here and the cards over here to be strictly less than 10. So that might be too much, right? So you want to make sure you can allow up to that particular bound. So Ryan, maybe that makes sense to you?
Yes, that makes sense. Thank you.
Okay, good. I don't want to make sure. So guys, I think yeah, and I think sometimes when I make up example question, I don't think they are invalid. They are also correct. Sometimes maybe the wording is not as being carefully made as the actual test. So I would say just take them like examples. I think for your test tomorrow, I believe there should be no ambiguity. But if there's any question you want me to clarify during the test, you can feel free to do so. I'll be there. Anyway. Okay, I see some hands raised on the participant here. Okay, I'll just go by the the order appearing on my Zoom. So Sarah, go ahead, please.
Hi, Professor.
Hi.
I think it was question 13.
13. Okay,
Yeah, I think it was 13.
go ahead. Yes.
Yeah. So why is it the option for D -1 when like for in it, like it's just supposed to be constants?
Okay, n becomes D -1. Okay, let me see this one here.
Because
Okay,
like,
that's a correct answer. Sorry, you're wondering about why it should be chosen?
yeah, because I thought that like, I don't know, maybe I was mistaken, but when I was reading the slides, it
Okay,
said
sure.
that,
So let's read the
yeah.
question together. They said, choose each that may be used. So whether it really makes a lot of sense. So here, this is more talking about whether or not you will compile on the road. So they may be used. Whether or not it really is really logically correct or even logically making sense. That's not our concern. So over here, D is a constant. Yes. So here you can see here, we can either initialize the n to be 0, that's okay. We can also initialize the n to be the constant -1. So that means initially our island bridge compound already got maybe 9 cards right in the beginning. That's also possible. And this one here, okay, let me see. From what I can see, we choose that maybe, I think there could be a typo over here. If I listed n equals 10, as a correct answer. So apparently the syntax is not right? I think that this should be a typo. It should be called an equal, right?
Okay, yeah, that
That caused some confusion. Yeah, so that's yeah. Apparently, well, if of course, I could test you the other way. If I really didn't really mean this to be a typo, in that way, that shouldn't be there because it's not correct syntax. In the action part for the events, you should always use the colon equal to say the variable becomes this value in the post states. But here, apparently, it was a typo, right? Over here, for sure.
Okay.
Yeah.
Okay. And also, I have another question for ORL, right? And you have like, once you do that, like you have two disjunctions that you got to prove.
Mhm.
But let's say one of them, like you can prove it automatically, or like it can be proved, and the second one you tried and you get stuck somewhere. Does that make the whole like sequence like not provable?
Yes, it does. It does. Okay. So let's say this. Okay. I do see your question here. I don't quite remember like which example we did in the lecture that actually made this happen, but let's now talk about in general. Okay. Yeah. So if you guys recall the ORL inference rule, right? That's something you'll definitely have to know how to use for sure. So let's say over here, right? Let me just copy exactly what you were given on the example. Okay. So now, by the way, so these links will be given to you tomorrow in the lecture in the test question. So you don't really have to strictly speaking, you just need to understand the rule and just get yourself familiar. Okay. So ORL over here. Okay. So let me just copy that and then I can speak about it. Okay, here. One moment. Let me just copy them. Somehow my universal clipboard is not really working. Okay, give me a moment. I'll copy that down. So HP or Q, turnstile R, and then HP, and then R, HQ, R, and that's the ORL. Okay, now let me switch. Okay, let's say this inference rule. So the question was, let's say we started with some sequence over here in the beginning. At some point, we ended up with some other sequence over here, and then we actually got over here ORL, means the OR appears to the left of the turnstile, which means it will be part of the hypothesis. Let's say for some reason, for whatever reason, we actually got, let's say X or Y, okay? And then you got some dot, dot, dot over here, and then you have the goal to really prove over here. So now we can actually apply the ORL rule by saying that we can split this into two sequences by applying ORL. In that case, we're going to get dot, dot, dot over here, and X turnstile, and then the same goal over here. So this will be 1. And then another one would be here, and then we still got dot, 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 and we got Y. And Sarah, I believe your question was, let's say for some reason, now after a series of steps, you are able to terminate this with maybe some axiom inference rule, so you can prove it. But somehow, maybe after several inference rule application, you actually run into this particular one where you cannot really prove. That's kind of situation you're talking about, right?
Yeah.
Okay,
Exactly.
if that's the case, yes. So in this case, the original sequence is unprovable. Because in
Okay.
order for that to be provable, because somehow after the split, you're saying that in order to prove this, it would be sufficient to prove both this and this. But now, since you haven't really proved this, so the sufficient condition is not complete. So the original one is not provable.
Okay, that makes sense. And I
Okay.
was just also wondering, like I was doing practice from like your slides and stuff like that, but like I ended up having the same answer as what you had. It's just that my order for like the inference rule were not exactly the same, but it still worked out to be provable. I was just wondering, like on the test, because there's like many ways to do stuff. Like,
Yeah, there are
are
many
we?
ways. Yeah, there are many ways to do the same proof. So
Yeah,
I'm not too sure exact when you say the sequence is different. It could be that it's okay, or it could be that maybe at some point it might be the application was wrong. I'm not too sure. I haven't seen that, but I would say in general you're right. So for the same sequence, in order to prove it, you definitely got more than one proofs. It's usually the case. You just
yeah,
but I think for tomorrow, what you guys will see more likely is, for example, like what I keep saying in the class. Let's say if you're given, let's say one sequence on the left and then another sequence on the right, and then I simply put a question mark over here and asking, okay, so to go really from here to here, what will be the sequence of inference rule to apply? Either none, in which case you simply cannot transform from one to the other, right? That'll be one possibility. Or it could be just a single inference rule, or it could be a sequence of inference rule. In that case, the order, of course, will matter, because sometimes, well, for example, sometimes when we say apply monotonicity to drop some irrelevant hypotheses, and then you might do ORL, and then you might do stuff like that. In that case, switching these two may not actually work anymore. Well, it depends, of course. I'm just saying. So you have to be sure the order the order in which you apply the inference rule should be correct for each step. Yeah.
Okay, and as a follow-up question to someone who asked about like question 1 on the practice, I don't get like why we need to, like why we use monicity.
Yeah, so thinking this way, if you compare each one of the rule over here, right? We got P2 prime, we got P1, everything over here, and monotonicity, right? Including this.
Yeah.
If you look at the pattern for each inference rule, it turns out the only one that you can apply as a first step, right? Because remember this constraint over here, I said you should really apply, you should really attempt by applying as
Oh,
many as
okay.
possible, right? It's actually this bullet point that
Yeah.
actually kind of forces you to really try something, right? So given this rule, I think this might be a nice exercise for you. So I would suggest take a look at this pattern over here, and then try to compare the pattern for each of the inference rule mentioned over here. You'll find that the only one that's applicable will be monotonicity over here.
Yeah.
So
Okay.
by
Okay.
applying this, basically you can drop one or more hypotheses, and after that, you're basically stuck, right?
Okay.
Mhm.
And also my last question is on the slides, I think page 49, I don't know if
49?
it was
Okay.
a typo.
Yep. Could be. Let me take a look.
Yeah,
Oh, you mean this one here, right?
yeah.
You know what? Actually, I definitely fix it maybe on the version in my computer. So, okay, you know what?
Okay.
Yeah, I did identify this. You know what? Maybe it will be too late to update it now, but please, if you guys are still wondering about this, it should be n becomes n plus 1. So a becomes should not be the case. When I updated slides for the second refinements, you will see the updates for sure. Yeah, but I just haven't really updated the latest version. Yeah, it's definitely a
Okay.
typo.
Thank you, Professor.
Okay, no problem. Okay, let me answer some chat very quickly, and then I'll go back to the raising hands. Okay, give me a moment. Okay, are we going to be given all the inference rule? Yes, it is going to be. Yes. So basically, it would be something very much like the example here. So I think so far we covered 2 sets of inference rule. We didn't get a chance to cover the final set, but we're going to do that maybe next week. So that'll be applicable for your exam later. But these are the only 2 inference rules you're supposed to know, right? I don't think I'm going to ask for any new inference rule for this written test. Not really. Okay. So that's one. Yeah, that's one question here. And for lecture 15, okay, abstract versus concrete state. Show how the last state transition happens for MLN. Okay. This is from Said. So Said, maybe you can help me understand what your question is. I'll go there first. Okay. Which page are you talking about? This page? Is okay. Is this page okay? All right. So this one here turns out to be interesting. Okay. So here you can see we got ML out over here, and then we got ML out. That's corresponding, right? So now if you try to do ML in, right? Let's say for the abstract version over here. So you can see, is it enabled? In that case, you can see 1 larger than 0 is actually enabled. So you can definitely take ML in. On the other hand, if you look at for this one over here, ML in, right? And in that way, let's check the guard. MLN should really have the guard C strictly larger than 0. Apparently for the concrete event, this is disabled. So what does this mean? That means in the abstract world, you should be able to take the MLN, but in the concrete world, you are not able to, right? So this is really about this is nothing inconsistent, but this will be something I will need to discuss together with the skip events for that's going to happen on Tuesday. So I can maybe delay that discussion when we meet in the class. I can talk a little bit more thoroughly. But I would say for this one here, just for tomorrow's test, you just have to remember, in order for you to really do a transition, you always have to check if the current states will satisfy the guard. In this case, MLN cannot be taken. Okay. On the other hand, MLN in the abstract world can be taken. Okay. Okay, Sai, I think that kind of answer your question, right? I hope. Okay, I presume yes. All right, another question here for question 13. Okay, let me see. Okay, let me see here. For question 13. Okay, again, over here. And you're wondering about n becomes 10. Okay, this one here, of course, again, is a typo. So it should be n, call it equal 10. Okay, over here. Okay, this whether or not this will actually violate the invariance, we don't know, actually, right? Because we don't really here we didn't really specify exactly what D should be. We only say D is larger than 0. But I can tell you that if you put this into rodent, if you say n is strictly it just becomes 10, it might complain that it's not able to prove that your n is less than or equal to D, because you don't really know what D is, but that's okay. Remember, when I read this question here, choose each that may be used as an initial action. We may use it, it might compile, but whether or not it can pass the proof for invariant establishment, that's another story. That's not our concern. Okay, maybe that kind of solve your question. Okay, just in case no, you can feel free to follow up. Okay. All right, let's say Shen Shang, go ahead.
Hi. I can hear me?
Yes, I can hear you. Go ahead.
Okay. Can you go to the question you are talking about the NL in the slide? I just saw that question and I still have some question.
Sure, no problem. You mean this one here?
Yeah.
Go ahead.
You just mentioned that the abstract can take NL in, but the concrete cannot take NL
That's
in.
correct.
But during the quiz, do we need to like write something like because we can use the skip, right? So
you know what? No, don't worry. You don't need to
so-
worry about. You don't need to worry about skip for tomorrow, since strictly speaking, skip was only covered on Tuesday. But as we said, we only cover up to certain slide number last week, so you don't need to worry about skip. So I think so. That's why I said for discussing why in this case the abstract event will be enabled, but not the concrete events. This would still be a consistent behavior for our model. But I'll try to address this maybe next Tuesday more properly when we meet up in the class.
Oh, okay. And I have another question is in our written test 2 guide, season 2, there have something called the format, and there are something saying
Written test 2 guide. Okay, which page?
Let me check. It's page 2.
Page 2?
Here.
Okay, what about it?
At the last line, it says there may be written question require you to write the validated ASCII to character for mathematic constructor. So I just don't really sure, because during in our practice test 2, I didn't saw anything related with ASCII.
Well, remember, right? Okay, I see what you mean. But remember what I said over there. These are just supposed to show you the format and workflow of the test, right?
Oh, okay.
And actually, there might be more question, right? It is not supposed to cover all the topics, right?
Oh, okay. So we still need to like try to remember those ASCII code characters.
No, yeah, I would say I wouldn't. If I ever ask you to write some ASCII syntax, right? It should be the very common mathematical operation that we use all the time. I wouldn't suddenly ask you to really write something that you never have seen before. Definitely not, right? And also, given that you guys have already gone through the programming test 1, so I think that this part over here should not be very challenging. Just make sure you review the mathematical symbols you wrote for your programming test 1 and other lab very quickly. Then I think that should be okay.
Oh, okay, thank you.
Good.
That's all
Okay.
my question.
No problem. Okay, before I go back to the next raised hand, so for the final exam, will there be programming? No paper. Well, it's going to be a paper exam in person, but you might be asked to write fragment of maybe some mathematics, either in mathematical like a paper form, like or ASCII form, either way. But there will be no rodent needed for the exam. Okay, it's going to be a paper exam. Okay. Okay, let me see. Hasaran, go ahead.
Hello, Professor.
Hi, go ahead.
I wanted to ask about question number 14, like
Okay, sure. Let's take a
14
look.
for
Yeah,
practice
sure.
test.
No problem. Yes, what about it?
Basically, I'm basically confused on how to approach this question, and even 13 and 14, basically both of them. Like I didn't know how to. Yeah.
Okay, let's. You mean 14 and 13?
Yeah.
Okay, why don't we do 14?
Yeah,
first?
both of them.
No problem. Let's do 14
Okay.
first. So let's say we need to define the action of the special events. Okay, and consider each of the following Boolean condition isolation. Okay, So we are talking about choose each that may be used as a guard of init. Okay, good. Okay, so basically this is now talking about the init events that we spoke about in the class, right? So conceptually, so init events is actually going to initialize the very first states of your system. Sorry, my Apple Pencil just got disconnected. There we go. Okay. So here you can think about for the very initial state for your model or your system is going to be done by the inits. So that means before this init, there's no such thing as pre-states. And also the init event is always enabled. Okay, so these are the two important facts you guys have to remember for tomorrow. Number one, there's no notion of pre-states of the init. And number two, the init is always enabled. All right. So given these two, right? So let's now go back there. Okay. Since the event is always enabled, so the only one that you can actually use will just be true, right? Logically. And actually in Rodent for the init, I don't think you're able to specify any guards for the inits. So that's why the only answer that's correct will be true. Does it make sense to you?
Okay.
Okay, that's for
Yeah,
14.
yeah.
Okay.
That,
And for 13 over here, okay, let me just try to maybe go over maybe in a slightly different way. So here, you basically want to specify how each variable is initialized, after the initialization for the system. So on the right-hand side of the left-hand side, is going to be some variable, right? In the M0, we only got one variable, which is N. In the case of M1, we got A, B, and C, 3 variables. That'll be the left-hand side. But the right-hand side here, there will be some constraint. The only thing you cannot put on the right-hand side will be just another variable. Because since there is no pre-states, so you cannot really say N is going to become its pre-state plus 1. There's no pre-states as far as init events concerned. So that's why E should not be chosen. It's simply invalid. You just cannot put it. On the other hand, you can put some constant. You can put some constant here, and then 10 or 0, and also you can put some constant -1. That's okay. And this one here is not good because the left-hand side over here is actually a constant. You cannot change a constant. You can only change variable. Make sense to you?
yes, no, it does. Thank you.
Okay, no problem. Okay.
And
yeah, go ahead.
also just one last question for the written test tomorrow. How many questions are we expected? Like
Oh, how
more
many?
than the practice test, or?
You know what? I haven't really finalized exactly how many questions. I would say it might be. I don't want to be really wrong. I would say it will be in the range of between 8 and 10, something like that.
Okay.
Around that range. Yeah, because I haven't really finalized yet. So I would say it could be just around 10, around.
Okay. And we have 40 minutes, right?
You got 41 minutes actually, not 40.
Okay.
Okay. Okay,
right.
awesome.
Thank you.
All right. No problem. All right. Okay, next one, Naba. Go ahead.
Hello, Professor.
Hi.
So for question 13, I'm wondering how come n becomes d minus 1? Because we're in the axiom, we're saying d is greater than 0. So let's say if we're initializing d as 1, for example, and then 1 minus 1 would be 0. If I'm
Yeah, I think here, so since we only say which one may be used as action of init, so here we're not really asking that to be provable, right? So here we're only saying what can be the correct possible syntax for that. So in this case, I can say I just want to have the constant value there and then -1. Yeah, this actually, you're right. This may not be a very legitimate, logically correct action to write. Because if you say n is equal to d minus 1, what if d is simply 0? Because d can be a natural number. Then 0 minus 1 is going to let n become a -1. In that case, you will violate invariant 1. I agree. So that's why if you put this one here, if you put n becomes d minus 1 into Rodent, it's not going to give you any compilation error. There'll be no syntax highlighting about something being syntax, but you're going to have some unprovable proof obligation. Because invariant number one, as I explained, is going to be unprovable, right? So it's kind of different issue. Yeah.
Okay, all right, that makes sense. Thank you. Another question is, I find myself struggling sometimes when I use the monotonicity inference rule. Is there a rule of thumb to what kind of rules I should drop right away and which ones I should keep?
It's a very good question here. I would say, unfortunately, just for proving sequence in general, there will be no like a always working answer. So I can give you some guidance, right? But the guidance is pretty general. Okay, I'll just, for what it's worth, I'll just mention that. But let me just find one of the proof we did earlier. Well, let's say for this one here, right?
Yeah,
let's say
for
you're
this one,
given,
actually, yeah.
let's say you're only given this sequence to begin with, right? And monotonicity in general, it doesn't need to be always applied as a first step. You can say, I will try to do some manipulation by using some other rule. And then finally, once I'm become a little bit clearer about which hypothesis I want to keep, I can use monotonicity. It doesn't really need to be used as a first step. The reason that for all the lecture example, I try to use the monotonicity is because I kind of know how the things should really go along. So I try to save the space. So I kind of drop all the irrelevant hypothesis right at the first step. That's kind of, in some way, it's like the most efficient way possible. But I think in general, when you were seeing some sequence for the very first time, I think it just basically trials and errors. You just have to try. So when you try them, you want to look at the goal over here. So if you look at the goal, it's going to involve N and D. So you should at least maybe try to keep all the hypotheses that have to do with the property of N and D. Typing invariance, that one's a little bit debatable. Sometimes it could be useful, sometimes maybe way too general. So you may want to find something that's a little bit more specific. For example, between these two, when you say D is a natural number and also D is larger than 0, apparently this one is more specific about D is. In that case, of course, you got to keep it. And then let's say you make some decision and then drop some hypotheses and then let's say keep some. And then you apply monotonicity you got here. And then you want to somehow experiment to see, okay, given what I have kept as hypotheses, can I lead my way all the way to axiom sequence? If you cannot, that means there's got to be something, maybe you did you dropped too much. In that case, you got to introduce something back, right? That's kind of like a iterative process you have to go through.
Okay, all right, makes sense. Thank you, Professor.
Yeah. Okay, no problem.
One more question, actually. Is that the test up until slide 64, or is it more than that? I'm just hesitant about
yeah, sure, no problem.
the coverage.
If I remember correctly, it should be 64. I initially said 60 before the break, and then I changed myself to 64, I believe. But let me double check. Yeah, it should be 64. Yes, 64 up to here.
Okay. Okay. All right. Thank you so much.
No problem. Okay. And then Adnan, go ahead. Hi, Adnan. Are you still here?
Hello. Hi,
Okay, good.
So sorry.
Okay. Yes, go ahead.
I sorry we actually went over this question quickly, but I think I ended for question 15 or 16. When you say old and new, I thought I had chosen them for the right reason, but now I think I haven't. So when you say old and new, because these topics were not covered, like the two new methods that we introduced in the last lecture.
Yeah. So and then here it's a little bit different. Okay. So I think when we first discussed about for Raphael's question, so that one there is about invariant preservation, right? For invariant preservation, you definitely should really consider both the old and the new events, basically concrete events. All the concrete events should be considered for invariant preservation. But what we are seeing over here is about Garth strengthening. And that one there, strictly speaking, is for just the old events. Like MLL and MLN. Only the old events.
Well, yes, that's right. But I was confused about this wasn't covered in the lecture for because this is like the topic of new events were not covered.
Yeah, you're right. You're right.
I didn't really think about it.
Yeah, I know.
When I did the test, but now I realize.
No problem. I think I kind of checked the test already, but I believe for the question you're gonna have tomorrow, I don't think there's any gray area. I believe everything that will be mentioned in the test tomorrow are strictly before slide 64. Yeah, I can see why it could be a little bit confused because we only talk about new events on Tuesday. Yes. I think I just take this maybe more like an example, even for your exam, right? But I think for tomorrow, I will try to review maybe once more before the test tomorrow. I don't think there's any question there that's gonna involve anything that we only discuss on Tuesday. I don't think so.
Okay, that makes sense. Thank you so much.
Okay, no problem. Okay, next one, wallet. Go ahead.
Hello, Professor. Can you hear me?
Hi, I can hear you. Go ahead, please.
Perfect. I have a question regarding slide 58 of the
Slide 15?
in the slides.
Okay.
58.
Oh, 58. There we go.
Yes.
Yeah, go ahead.
So in the second branch of the ORL, we use EQLR twice.
Yes.
As in the lower branch, sorry.
Oh, here. Oh, yeah. Okay, yes.
We use it twice. Is that a typo or is it do we just need to use it once? Because I can see how we applied it the first time, but I don't see how we applied it the second time.
Okay, that's good point. Let me take a quick look. The first time for sure, we are replacing every occurrence of C by 0. That one is for sure. Okay. And then I said I'm gonna do the second time. Oh, Wallet, that's good. I think you found some typo in my slides. Okay, yeah, you're right. This one here, no, you should not.
Okay, because that confused me for a second.
No, absolutely. I think you guys are good. That was the mistake your classmate from last year didn't catch. Okay, I'm gonna change that for sure. Slide.
And my second question.
Yeah, so sorry, just let me write it down. And then
sorry about that, yeah.
No worries. Yeah, so guys, just in case you didn't really quite follow, so basically over here, once we get to here, we can just drop these 3, and then we got 0 larger than 0. So this EQLR should not be there. Okay, yeah, Wallet, go ahead. Next question.
And so for the upper branch, when we applied the last arithmetic proof, shouldn't we be applying monotonicity as well? Because C less than or equal to N and greater than 0. Like one of
this
them
one
is
maybe
missing
not.
At that point.
Yeah, I tell you, this one maybe not. Because if you say you got monotonicity, in that way, you can drop either this one, which will leave to you C less than or equal to N, but that's not the case. Or you can drop this one here, which will leave to you C larger than 0, which is also not the case. So monotonicity is not a rule to really apply.
I see.
So
Okay,
this one here
makes
is
sense.
this one is more saying if I know C first of all is strictly larger than 0, right? And then let me see here. Okay, C is less than there we go. Okay, so I think this one here just in case I'll put it down on the iPad. Give me a moment. Okay, just in case you're not too sure about why we can apply arithmetic over here. Okay, think about, first of all, we have C itself is strictly larger than 0, right? It should be, for example, here. And then C is less than or equal to N. So N could be just equal to C. That's a minimum value. So N should be strictly larger than 0. That's kind of arithmetic we're doing. Okay, just in case.
I see.
Okay, good.
Yeah, that makes sense. Thank you very much.
No problem. All right. And Sarah.
Hi, Professor. I was just wondering for question 13, about the init question, can we also have like A, B, C initialized to like some constant? Would that be valid?
Oh, sorry, Sarah. Can you say it again? I don't quite catch exactly.
Okay, so like for question 13 on
13, okay.
Yeah, on the
Question
practice.
13. Yeah, go ahead. Yeah. What about
So we said about it was talking about N, but I'm also wondering about like A, B, and C. Would it be like right if we chose like if they had an option for A equals like some constant, same with B and C? Would that be right if we chose it?
Very good. that one then would not be right because you're given this model over here and you only got one variable called n. If I put a becomes, let's say 5 over there, it should not be valid because a doesn't even exist.
Okay, but let's say the variable does have a, then it should
Okay, let's say,
exist.
yeah, hypothetically, let's say here variables, we got a, b, and c, right? In that case, of
Yeah.
course, if you say a becomes 5, that's fine.
Okay, okay.
But
Thank
if
you
you
so
say
much.
a becomes b plus c, then that's not good, right?
Yeah.
Mhm.
Okay, okay, thank you so much.
Okay. Yeah, one question from Said. Okay, yeah, I see. So about the programming test 1, somehow I didn't include it in the e-post. So guys, I will make sure I include the programming test average, programming test 1 average. I got to check back on the spreadsheet provided by the TA. I'll update the e-post about the programming test average so you can check to see where you are. I'll do that. Okay, I'll make sure I do that. Hopefully by the end of tomorrow or even before the test, I'll do that. Okay, no problem. Yeah, guys, you still have 10 minutes. I'll give me a moment. Okay, I'll write down this. I should release the programming test 1 average. Okay. Okay, good. Okay, Shen Sheng, go ahead.
Hi.
Hi.
I just like a little bit confused about the
Mhm.
ORL.
Okay, what about it?
Why we have to prove the both sides? So in order to prove the one at the
Okay,
bottom.
what? Okay, so if I understood your question correctly, you're not really having trouble about splitting, let's say, sequence into 2. You're just wondering about why we could do that, right?
Yeah.
Okay.
It's like the OR is like all. It seems like we only need to prove one side, but why we have to prove both sides?
Yeah, for that one there, yeah, bear with me. I'll tell you where you can look at, right? That one definitely was somehow covered, but I'll show you where you can find it. Okay. So, okay, give me just one moment. I'll find it. When we first talk about that inference rule, okay, guys, bear with me. I want to be precise about where we can find it. Just bear with me. Possibly here. Okay, let me see. Because I think that there was a certain proof you can actually do to justify the inference rule. I want to show you where exactly you can find it. And there was even some recorded video to actually show to you. Okay, not that early. Okay, so let me check very quickly. Okay, this one here, EQLR. Okay, I think it should be before. Okay. Okay, I think, okay, before that, how about this one here? Oh, sorry, that one's the review. Okay, could be this one. There we go. Okay, almost there. Okay, there we go. Right, this ORL, right? So basically, you can formulate this. Okay, let's understand again what this really means. So I think one of the example question actually tested you on the basic interpretation of the inference rule. We are saying that in order to prove the button, which is a single sequence, it would be sufficient to prove the 2 sequence independently at the top, right? And we can formulate the following to say, if you're able to prove the top, P implies R, which is over here, and also Q implies R over here, if you're able to prove this, it can lead to the fact that P or Q implies R. And if you try to prove this particular implication, it's a theorem. Okay.
I see.
If you're interested, I'll just show for those of you who are interested, there is actually some nice little proof you can refer to. It's actually even here, right? If you click on that, that one actually goes over that proof starting from here, right? If you're interested, take a look. I think you will answer your question completely.
Oh, thank you. Yeah, if you told me that it's like we combine 2 things and then we have some proof and then we get that end, then I understand why we have this
Yeah, exactly. I
this-
think for all the inference rule that we spoke about, especially for those that's slightly more like a complicated pattern, you can always try to formulate it using like a conjunction, implication, and then you get down to basically what you're familiar with back in 1090, right? You can always try to do some little bit extra proof yourself. Either, well, of course, accepting them is one thing, so you can use them. But on the other hand, like what you're wondering about, whether why do they really work? They have to formulate it using implication and then try to prove it, right?
Yeah. So
Okay.
much. Yeah, that's
Sounds
the
good.
only
No problem.
question.
Okay, Sarah, go ahead.
Oh, sorry, Professor. I just forgot to lower my hand.
No worries. Go ahead. Oh, okay. No problem. All right, guys. Any more question for today? Okay. Yeah, for tomorrow, if it is possible, I would suggest maybe make sure you are able to use your dual mobile and also log into your PPY into eClass. I think one of my students in the test yesterday, somehow their PPY wouldn't work. So they actually wasted some time. So I would say just make sure your PPY work and the dual mobile for tomorrow. Okay. Okay. Okay, Shen Shang, go ahead.
Just last question. Do you have any suggestion for us to review for our written test too? Like, should
Any
we just
suggestion? Well, the
yeah,
official
just,
answer
should
is
we go
review
through
everything
those?
that's covered, right?
Yeah.
Well, but I would say you guys may want to focus more on well, I'm not saying you should really you should not do anything else, which I didn't mention, right? I'm just saying you should really, if you got extra time to really review certain things, I would say you want to look into reviewed again the two sets of inference rule that we actually have covered, and then make sure you're able to apply inference rule given some sequence, right, for as many steps as applicable, and to prove something or to show something that's unprovable. I think that's something you want to definitely make sure you understand. And also, some basic idea, some the concept about guard strengthening and also refinements, invariant preservation. And also, yeah, since we didn't cover skip, so you don't need to worry. But I'm just saying, whatever that's really specific about refinements, you definitely want to make sure you also review. Okay, here, Adnan, will lab number 3 help? I would say no. You don't need to worry about lab 3. Okay, I think lab 3, I'm gonna release your part 2 very soon. So I would say for tomorrow's test, you don't need to worry about lab 3. No. Okay. Okay, give me one moment. Let's see. Okay, one question here. Okay, it's private, so I wouldn't identify the students. Okay, is the question I'm gonna ask tomorrow going to be specific to the bridge controller, or would it be given different scenario? I would say you can assume most of the sequence you're gonna see tomorrow will be more or less similar to what you have seen in the bridge controller. I might ask you something specific about the bridge controller, but that should be the very important details that you should know, right? So I would say mostly it's going to be about bridge controller, but sometimes I might say I take some sequence from your bridge controller lecture. Well, for example, let's say I'll give you one example. Let's say I might take this particular sequence over here, and then maybe I simply drop some of the hypotheses right away, and so that appears to be like a new sequence, but you should still be able to actually prove it by yourself, right? Something like that. Okay, and then let's see. Okay, okay. Will you be asked to recall specifics? I wouldn't say no. So I would say try to definitely understand the flow of the logic about the bridge controller example. I think if there's any usually if there's any detail, I think that's really too subtle. In that case, I might just give you a little bit recall, maybe in the question itself. If I didn't really give that to you, that means I thought that's something very important for you to really remember. So I would say it's not really that many slides, for this written test too. Well, I know 64 is about a lot of slides, but you're gonna have even more slides, when you cover when we talk about the exam. But I would say try to really know all the important lessons that we learned from this case study so far. I think that's important. Yeah, for sure. Okay, let me just make sure I didn't miss anybody on the chat. That seems to be fine. Okay, Naba, go ahead.
Yes, sorry, just one more a quick question. When we reach to false left, that's still a hypothesis, right? Like that's still an axiom. We reached something, right? It's not a fail.
You mean when I reach the false L?
Yeah.
That one, yeah, that one indeed is the axiom inference rule. Because when you actually got your hypothesis simply just equivalent to false, because false implies anything. So that means you have
Oh,
nothing
yes,
else to
yes.
prove, right? Mhm.
Oh,
Yes,
yes,
yeah, okay. Yeah, Adnan, thank you. Okay. So yeah, similarly, I think that's something maybe that'll be mentioned later. I'm not too sure if we covered that. Symmetrically, if you actually got a go itself reduced to just true, in that case, anything implies true. That will also be axiom inference rule. Okay. All right, guys. So we still have strictly 2 minutes if you want to ask me more questions. Otherwise, yeah, I would say good luck to tomorrow. Okay, I'll see you all tomorrow.
Hi, Professor.
Yes, go ahead, please.
I just saw one thing. Maybe you didn't mention earlier. It's like the dialogue freedom. Do you think we also need to?
Yes, absolutely. Yeah, I just forgot. Didn't come to my mind. Yeah, you know, as like what I said, the official answer is you should really review everything I mentioned in the guide.
Okay.
I wouldn't test you anything I didn't mention in the guide, but at the same time, you want to make sure everything I mentioned in the guide should be reviewed. Yeah, that should be the principle. Yeah.
Okay, thank you.
Okay, awesome. Okay, another quick question here, very quickly. Okay. For the sample question, okay, so okay, interesting. So it turns out this question here got lots of doubts. Okay, again, question 13. Why is this not good? Because D is a constant. You can never modify a constant. Okay, yeah, okay. I see your classmate was trying to help you. All right. Yeah, you can only modify the value of a variable, not a constant. Okay. Okay, no problem. Good. All right, guys. It seems like you guys are okay. Yeah, do some last minute review, and then I'll see you all tomorrow. Okay, take care. And then I will try to post a recording. If you still need it, you can expect it to be available possibly a few hours later. Okay. All right, you guys, take care.
Thank you.
See you tomorrow. Bye-bye.